Hi, good morning, everyone. So I welcome everyone part of AWS UG Coimbatore group for this wonderful session on this Saturday, 5th of August on generative AI and serverless tech concept. So we'll start with generative AI concept from Supriya. So Supriya is very, very popular among the community. She has been, contributing a lot on machine learning and AI related topics for different forums. I'd like to give a brief introduction. Supriya is currently a vice president of data science at JPMorgan and Chase, and she was top 10 Indian women data scientist in the year 2021. And she was recently selected for a Google Women Tech Makers Ambassador program, and also she's a new nominee in Women in Tech Global Awards for 2023. So we have a very powerful, speaker here, and followed by another popular and powerful, knowledgeable speaker for the serverless topic. So with no wait, I would like to bring Supriya on screen. Hi, Supriya. Good
Hi,
morning.
very good morning, Raghav, and thank you so much for giving me this platform. I welcome all the people, participants who are actually listening to me, and I'll make sure that in 1 hour, whatever we cover through generative AI is actually, very helpful, or at least it will scratch the ground, and you can go back and start exploring more on generative AI.
Thank you. Thank you. Yeah. So with no wait, I will hand it over to you, Supriya, and we can look into the session. Thank you.
So, we will start with today's agenda, which talks about what exactly we will be covering today. So, today's agenda, we will, before we land up in generative AI and talk what generative AI is, it is little important to understand what natural language processing itself is. So, we will briefly touch on that. And because generative AI, when you say generative AI, it's all deep learning, which has, merged into NLP. So, what deep learning has been, and we have a phase where when you say generative AI, so natural language understanding, we call it as natural language understanding and natural language generation, NLU and NLG. So there had been an evaluation of NLP algos, pre and post generative AI. So we'll talk about that. And any model which you take through any of the large language models which we have today, they are primarily based on transformer. So we'll talk about what transformer had been. The first transformer model which has been actively launched into the market was BERT. So we'll talk about BERT, which was encoder only model. We'll talk about what is encoder and decoder. But there are some models which are encoder only. There are some models which are decoder only. So the BERT was the first and encoder only model, while all the GPT models which we have in market today are actually decoder only models. So we'll talk about both. And finally, because we are talking about generation of the text, right? So when we talk about that, we have to be very responsible about how we use the AI, and that's why explainable AI or responsible AI becomes a primary factor, and that's why we will briefly touch on that. At last I'll talk about some of the models which we were using in banking, and finally how AWS makes it a best place to use the generative AI is the last topic which we will cover through. So with that, let's start with what NLP is and how deep learning came into picture. So when we try understanding text, right, there are primarily three factors, three stages in which we understand, and this had been a very primitive way of understanding it, but it makes a lot of context in understanding why deep learning came into picture. So in primitive algos which we had, we used to learn text by first the at the bottom you can see there is lexical processing, where you actually tokenize the text and you only try to understand each token or each word in separations. So the best example can be spam ham example, where if you have to classify a mail by spam or ham, you actually don't go by the language or anything, you just concentrate on the keywords which are present in the mail. The second stage was syntactic processing, where we understand little more than just the tokens or the words of the text. So we try to understand the language of the text. And when I say language, we generally refer to the part of speech, like whether it's a noun or it's a verb, or whether it's subject or predicate, and all those, considering all those together, we try to process the text further. And the last stage was semantic processing, where it actually means that when a text has been given to you, you don't only process the text. The best example can be that when I say the cat is moving, as soon as I say that cat is moving, as a human, we can visualize the cat in our mind. We all know what a cat is, right? So those are actually the semantics, where you don't process the text which has been provided as is, but you need a lot of other, that's why the general knowledge or the domain knowledge and the discourse context, all those had been fed in addition to the text which we want to process through. But late like it is not recent, but in 2017 or 2017 was when transformer came into, and deep learning started getting embedded. Before transformer also, actually, we had so we'll talk about deep learning might be, and then we'll go to that. But before we go to the deep learning aspect of how it stepped into text, we will like to answer a few questions, right? So the traditional machine learning, when we talk about a traditional machine learning, right, the traditional machine learning was actually where you can feature to the text, right? So if I ask you the first question, what factor do you think impact the global oil price, right? We all have known factors, right? We know the factors, like some of us will say the political conditions of the country, or the political crisis, or might be the global demand and supply, right? So there are surely the factors which we can call out when we have to figure out the impact on the global oil price. And that's why the traditional machine learning models actually require the feature engineering. We had feature engineering. But look at the next question which we have. It talks about what factor do you think you will use to recognize your son or a daughter, right? So if you have to recognize any of the person, right, how will you describe that person? No matter how much we describe, there is no unique way of defining a particular person, right? And the same thing happens when you model such things, right? So if you model a image, or if you model audio or a video, how will you make sure that the model actually recognize it correctly? So this is the next picture which we have. When we say deep learning, it's a combination of two things. It's a combination of neural network and the reinforcement learning. The first picture here is shows that if you have a image of a bird, and if you have to classify it whether it is a dog or a bird or a cat, how will you do that? In order to do that, no matter how much you describe that this is the beak, or this is a color, or this is a background, you cannot limit the features. And that's why we need deep learning, because when the deep learning works through, it defines the layers of the layers of neural networks which has been defined through. And it auto extract the features of the images, and then works through it. Also, I will touch briefly on reinforcement learning, because reinforcement learning is something which came again long time back. But when we say reinforcement learning, it actually means that if you have, like, think of a robocar, right? So you cannot again feed the robocar what exactly it has to do, but it learns through the action it takes. So it's a continuous iterative process which happens, where they learns through the action they take, and then it goes back into the environment, right? uh, the pre-generative era, because this is I put a slide here to talk about the pre-generative era, but primarily let's go to major milestone which happened after post-generative era, right? So when you talk about generation, we understand that we are no more trying to just classify the text or get a regression model, or might be extract the sentiments, no more. But we are trying to generate the text. And when you talk to generate the text, it is actually based on guessing the next token, right? So if you have been given a pattern of token, if I say you are going to and dash, so dash is something which you have to fill it, and it happens again in iterative way, and that's how the generation happens. So when you talk about generative AI, it actually starts with GAN, which was launched in 2014. But GAN is not the base of all the models which we have these days. Primarily, all the models which we have today is based on transformer, which was launched in 2017 by a Google paper, which was attention is all you need. So we will talk about what is attention, but what I want to show you in this slide primarily is after transformer, soon after transformer, the GPT paper came, and then GPT 2 3, and then all the GPT model. When you talk about GPT model, they are constrained to the text, but now the generation is not only in the text. So we also talk about the diffusion model, which you might have heard about Mid Journey and other such models, which came into 2022, where you actually enter the text, and it actually generated an image for you, right? So diffusion model is for images, and GPT models is for text. And the most recent one which we have is GPT 4, which came in this year only, 2023. So, what is the use of transformer model, right? Let's clarify that. So, we talked about that transformer model came in 2017, and the first paper when they launched it, it was actually meant to do the translation. Okay, so when they were launching the transformer model, the whole model was based on the experiment that how effectively this model can actually translate one language text to another language. And very soon after, because these are pre-trained model, when we say pre-trained model, it is actually the model which has been trained on a huge amount of data, and we have the weights available. So you don't need to retrain from scratch. Rather, you can use this pre-trained model and you can build on top of it. So it saves a lot of amount of compute, it saves a lot of amount of time, and so on. So soon after the translation use case work through, it went through many other use cases like essay writing or summarization, and so many more, right? So primarily, what is transformer, right? I have been talking about transformer game, and it comes with the paper of attention. So what is transformer model is what we will understand first before going to generative AI. So in this picture, if you see the first picture, it shows, right, it says I am good. So you feed this input to the encoder will generate the representation, and that representation is nothing but the word embedding which the encoder provides. So this word embedding get fed into decoder, and then decoder will finally give you the translation of that text. This is was the primarily the base experiment which they were doing with the transformer. But later, and also the below picture, it shows about the BERT, because as I said, not all model uses both encoder and decoder. So the first model they launched on transformer was BERT, and BERT was actually encoder only model. So the next picture which you see below, it actually shows you a stack of encoders, where each encoder is very similar to each other. They are exact replica. But when we say encoder, it is not just encoder, but it is a layer of encoder which work together. And also, when the paper came, right, a transformer paper, it came with six layer of encoder. While when they launched BERT had two models, the base model and the advanced model. The base model had 12 layer of encoders, and the advanced model has 24 layers. Now the question is, which one is best? Of course, the model which has more layer of encoder will have better accuracy, better metrics. But then again, there is a huge trade-off between how much metrics, accurate metrics you need, to the cost you incur through, right? So if a base model can give me accuracy which is good enough for me, might be I will not go for advanced model, just because all these model, as I said, are pre-trained model, and it require huge amount of compute, although they are pre-trained. But even if you use those pre-trained and you work on your model, it is a lot of amount of compute, right? So there is always a trade-off between what you exactly need versus which model you want to use through, right? And also transformer model, when I said we have encoder only model and then decoder only model, and we also have some models which has both encoder and decoder. We'll talk about this more. So this is a picture here. It actually shows the original transformer, and at the top you can see we have encoder only model. So we talk about BERT, which came in 2018, and soon after Google launched BERT, there had been various variation of BERT which has been launched by other organizations, which were very similar model to BERT, fulfilling their gaps which they found out. The recent model which we have, which I showed you through all the GPT model and the chat GPT, they are all decoder only model. And at the base you can see encoder and decoder model both. So when we say both encoder and decoder model, we have Alexa T5 or Flan T5 and BART is different from BERT. So there are different models which has been launched through encoder and decoder both models. Now, before we go further, it is important to say what is attention, because the transformer model is based on attention, and we understand that all the large language model, including all the generative AI models which we have today, are based on transformer. And the best part which transformer launched was attention. So, what is attention? If you see this picture has been taken from the paper. Attention is all you need. This is exact picture which has been kept through. So you can see the smaller part on the left side and the bigger part of the picture which is on the right side. Sorry. So the smaller part is actually the encoder, and the bigger part which we have on the right side is the decoder, right? So if you see here, both the layer will show you multi-head attention, right? So multi-head attention, these are the attention layer which is actually making a difference. Also, the other thing to note is the input to the encoder and decoder layer is not only the embeddings, right? So generally we used to just provide the before transformer, mostly the input which had been given to the models were the embeddings of the text, right? So just to give you a simple example, in a sentence if you have 10 words, then it will actually create an embedding for all these words, and that has been serialized through the model to feed through. But what is difference here is we also feed the positional embedding, and we will talk about what is positional encoding. So not only the embedding, but you club it through the positional encoding also when you feed it to the transformer layers. So this is the example which talks about what is attention. Now the first picture here, it talks about one of the example. The picture says the dog ate the food because it was hungry, right? Now if you see the word it, right, it actually refers to dog, but there are two nouns before it, right? We have food and we have dog. But as a human, we know when we say it was hungry, it is actually referring to a dog, not to the food. So what how did we relate to this, right? How did you relate to this? And in order to create that relation, that is what is called attention. So that's why and when you say multi-head attention, right, multi-head attention is nothing but it is a scalar dot product of all the attention. You can see the below picture which shows multi-head attention. So when you have several layers of attention models, and then you just take a scalar product of that, that is what multi-head attention is. But to understand the attention, might be I'll bring you the context which will be more simpler. So there are three questions, and let's try to answer this. The first question says here, it is a glass of orange dash, right? If you like to comment, might be I can read through. If you like to answer, how what would you like to fill up in a it is a glass of orange dash, right? So if I ask you this question, how will you fill that blank? Any responses? Okay, so see, if you
Yeah,
say
no
it's a glass.
response. Yeah, maybe I would like to be an audience. Like in general, if I see, no, I got one response. So basically, Vijay Raghavan Vasudevan mentioned orange juice.
Orange juice, right? So it's a very correct thing to say that, as soon as you ask this question to someone, that it is a glass of orange what, then they will say juice. And why did they say juice? Because they might be referring to orange or they might be referring to glass, right? The next question again, the cloud are in the dash, right? How will you fill it? Might be some of us will say sky, and I ran this with some of the college students, and they say the clouds are in the server. So that is also true. But how are those fill in the blanks coming up? Because they are relating to the word cloud, right? But if you see the last question which I have here, it says, I met this French girl, Emily, in the conference last year. We fell in love instantly. My parents are conservative, so I planned and organized a blind date with my parents. They loved her. My mother hugged me right after Emily left. Even my dad gave me that rare wink. I'm so excited. All that is left is to convince Emily's parent. Here I am booking my ticket to Dash. What? How will you fill this blank? What?
Yeah.
What should be the answer? Right?
Let me
Mm,
see if any response comes.
yeah. Okay, might be, in respect to time. See, this word actually is talking about where should a man be going, because this is a French girl, so he might be primarily going to France, right? So as a human, we can actually relate. But if you see the text generation, the generative AI is actually the generation of the text, right? You are generating the next token of the word. Now if you give it to model have to actually refer through all this text all the way back, I think almost two sentences back, in order to figure out that the person might be going to France, because even the word France is not there in the text, right? So the person might be primarily working on some word to get a reference through. So as a human, it is very doable. But when we do the models, right, when we do the models, we have to set this context, and that's why positional embedding becomes very important. Because when you want to derive a meaning or a context in a text, it is not only the word itself, it is not even sometimes the sentence itself, but it is some sentences back which you might have to refer in order to get that context, right? And many times we also saw that when you are doing the semantics, right, it might not even be in the text, right? You are trying to derive a word which you already know, right? If I say the cat has a long dash, might be you will answer tail. And why did we answer tail? Because we know that a cat can have a long tail, right? So we have that context set in our mind, and that's why that context had to be set in the models also. Important, it is very important to set that. And this is how it happens. The first picture is shows that when X is actually the text embedding which you have for each of the text which you have, but you combine it with the positional embedding, and then you figure out the final embedding which you actually feed into the encoder or decoder model, whichever you have, right? So when you say positional embedding, it is not it actually literally means like it's a position in the sentence, but it is not that simple. We generally generate the positional embedding using either the sine graph or the cos graph. That's what the second picture below is showing through. That if you have to generate the position, then you generate it using the sinusoidal graphs and other things, and then you combine it with your actual embedding, and then you feed it into the model. So the last picture which we have here, it shows that you are feeding the text, but in addition to the text, you also feed the positional encoding, and then form the then feed it to the encoder. And this is the final BERT model. As we said, BERT model is encoder based model, right? So when we say encoder based model, it's a layer of encoders which we have, right? The one of the encoder has been enlarged for us, and you can see that it has a multi-head attention and feed forward network, which is very important, which is marked in orange. And then you have very similar structure. All encoder have the similar structure, and it actually goes through each of the encoder, and finally it generates the embedding, which is actually useful for us, right? So with that, might be I'll talk about one of the use case which we worked on with the bird, and this is actually the actual use case which we have worked in one of the financial organization I have been working through. So I'll briefly talk about this use case, and might be then we will start talking about more of the generative AI. So this use case was primarily on complaints. This was developed peak COVID, when we were in COVID. So you might remember in COVID when we started, right? Suddenly everything started. We were made to work from home, which we never expected. So everything had a pressure of having digitalized, right? Which we never thought we will do it earlier, but it happened at that moment of time. And this is about the complaints data which we had for the operations, for the banking. So when the complaints come, right, and if you are a bank, if you are in a financial institution, the complaints can be two type. It can be a breach or a non-breach. If a complaint which has been registered by a customer is a breach, then it is very important that you address it within a stipulated period of time. If you're not doing that, there is a heavy fine which get imposed onto the banks, right? So earlier, because the complaints were limited in number, the operators were able to anyway handle it. But because in COVID everything got online, right? So the number of complaints actually increased, and we needed a very simple model which can actually be placed on a huge database. So the complaints data set was actually very, very huge, right? Which can be kept on the complaints data set, and which can only predict that whether it's a breach or not a breach. So what will we do if we predict that? If it is a non-breach, then operator can take its own time to answer through. But if it is a breach complaint, then it becomes a very high priority for the operator, and then they have to immediately address it. Also the breach, when you say the breach conditions, there were 13 different type of breaches that organization had. So when the model actually what it does, it takes up all the complaints requirements which you have, it passes it through our model. And the model was simply, the BERT model was simply doing the text classification, classifying it into breach or a non-breach. And later we also did it although the picture shows binary classification, but later we expose it to classify it through different layers of breach, because even in the breach some of them are very critical, some of them can be handled with some amount of time, right? So it actually used to classify it into 13 layers of breaches which we had, and then non-breach, right? So this was one of the use case which we worked through. With that, we will now start with generative AI. Now we understand that we had a transformer, and whatever till now we talked about was the history of transformer, where they actually started with the encoder only model. And I talked about primarily BERT, because BERT was the primary model which they started with, and many other variations we have in the market. Now when you talk about generative AI, these are decoder only models, and all the GPT model which you talked about are actually based on generative AI LLM models. So the first question here is, what is generative AI? When we say generative AI, it is actually about generation of the text, which we understand, right? It is no more using the text as is and then predicting something or just classifying something, but we are actually generating the text. I hope most of us have might have used chat gpt, the interface which we have. And it's very, if you have not used, I will request you to go back and check, and it actually answers so smartly, right? That the UI which has been provided, so use those playground and play with it. When we say generation of the text, it cannot be, because I'm primarily talking about text, but when we say generative AI, it can be generation of anything. It can be generation of text or images or audio or video. Even when you give a text and you suppose you want to say generate me a picture of a red apple, and it can generate you. So from text to images also generation is now possible. Now the next question is, what is LLM? So we talked about this. LLM is large language model. These are pre-trained model which has been pre-trained on huge data of internet. They have, and then there are different versions of LLMs which has been provided through. The effectiveness of using this LLM is you don't have to go with the primitive way of treating the text where you tokenize, and then we used to first remove the stop words, and all those steps has gone through. You can primarily use it, and it speeds up your task a lot. Also, if you want to fine tuning it is very easy to do it on these large language models. The next question is, are all large language models generative AI? And that is not true, because the LLMs can be used for natural language understanding, which is NLU, or it can also be used for natural language generation. And the last thing is, what are the different models? So we talked about the GPT models, and we also talked about diffusion model. As soon as you talk about diffusion, it is primarily with images and videos. Now, till now, we are only talking about the models, but we also have to understand that these models actually incur a lot of cost in many other things, which has to be supplemented along with it in order to get it executed. So, what are those? And that's why I have kept it as LLM framework. When you say framework, the bottommost part of the slide, it actually starts with the hardware. So you need very advanced chipsets which has to be provided. It mentioned NVIDIA is some hardware chipset which we are primarily using. Even I will talk about some of the chipsets which AWS itself has launched recently, and they are primarily used in order to train the generative models. Also, the second layer on top of it is about the cloud platform. So, in order to execute this model, we are very clear that it will not run on a normal machine, which you and me have on a CPU machine, right? So, we need heavy compute, specialized to run these kind of model, and that's why to incur them and have it in our own premises is a huge cost. So most of the organization, not only organization, as an individual also, we prefer to do it on cloud because cloud platforms provide pay as you go. So you get very specialized compute which can enable you to do such models easily. And also the top, at the top somewhere, you can see there are model hubs. So as I said, there are so many models which are available. Which model should be used is again a question, and where to use. And that's why there are libraries of models which are available, like Hugging Face is one. We You might have heard about Amazon Bedrock, which is now come in beta version, and we have Model Hub which has been provided to. So you can choose your model. Very The choosing of the model is a primary thing which we have to be very selective on which model you want to proceed through. And then there are a lot of apps which has been developed on to top of it, which can be end-to-end models or B2B or B2C kind of applications which has been developed. So the next thing which we will talk about is generative AI life cycle. You can see we always start with the scope. So defining the scope of the generative AI is very prime thing which we have to decide. Suppose I am developing a chatbot, right? So chatbot can do multiple things. The chatbot can be an interactive chatbot, a smart chatbot. At the same time, the chatbot can do multiple other things, like it might be extracting data from a large language repository you have, or a chatbot can also be used for, might be, the translation of the language. So what will be the primary objective of your chatbot, or what is the primary objective of your generative AI project? That scope should be very well finalized and documented well in the very initial phase. The second thing is about selection of the model, and that's what I was talking to. I will just give you example because I belong to banking, right? And specifically from payments. Now, if I have to build up a model on which I want a chatbot to be developed for my organization, might be I'll go through some base model which are already available, which are pre-trained on, might be, banking data. Or more specifically, if I say, because I'm in payments and if I have to develop something in payments, might be I'll go and check something in payments, right? Some model which have already been done. So, and so on. Suppose a person has been working in a medical field and you already have a model which has been pre-trained on the taxonomy medical terms, it is more effective to use that as a base model rather than using some random model, right? So choosing the base model is again a primary thing which we have to be very considerate of. And then on top of it, although you choose this large language model, and large language model in itself are very smart, but then there are multiple other factors which make this model more efficient, and there are three different things which we will talk about. One is prompt engineering, then fine tuning, and the final one is RLHF, which is reinforcement learning with human feedback. These are the three things which we will talk about, that if we have to use a base model, still how we can optimize it for our own, or might be customize it for our own requirements. Um, then finally you have to evaluate your model, and the last part, the green part, talks about deploy and the build of the large language model, mainly in the production regions, right? So we will start with first understanding what is prompt, and you might have heard the prompt engineering everywhere. So when you have a large language model, we all understand that primarily we give it as a text. Text is given as an input, and the large language model will give you similar kind of text, because they are generative AI. Now that we understand they are generating text, so they will be primarily giving you some generation of the text output. So although it is an input and output to the LLM models, they have very specific terms, and we will stick to these terms as we go through the next slides, which is prompt. So if you provide an input to your LLM, it is called prompt, which is kind of text which you have provided input through, and then whatever the LLM model is giving you a response, that response is called completion. And this prompting, right? The more effective your prompt is, the better answer you will get, and there is a science behind creating this prompt. So that's why I have mentioned chat.openai.com at the end. Might be if you want to play with that, how the prompting works. It is they are very smart way of writing the prompt, and the more effective way you write the prompt, the better answer you will seek through. So just to give an example, there are three different approaches which I have kept into the slide. One is the first one says a zero shot. So when you say short, it's short actually means examples. How many examples which you can supplement when you are querying through this large language model. So if you provide examples along with your questions, then that is what is called one shot. If you provide one example, then it is one shot. If you provide multiple example, then there are few shots. So the first example which you see, it is asking to classify the review, but it is not giving any example. While the second example, because it is giving an example, it is giving one text and it has already classified it, and then it is asking the second question and it is asking to classify. So it is a one shot prompting which we have. And similarly, you can have few shot prompting where you can provide multiple text, right? So that's what, not only the examples, but then there are many other things which you can provide along with the examples. Like you can define the role. As soon as you say that you are an experienced mathematician and you have to solve this math question, your answers will be very different from what you have not provided. Or similarly, if you say, if you can provide guidelines, like suppose you say in prompt that you have to solve it step by step, then you give a math question, right? Then you will see that as soon as you say step by step, it will actually explain you step by step how to solve it, and then it will make it more interactive. So we can play a lot with the prompting, and the more effective the whole crux is, more effective your prompting is, better results you will be getting when you are querying through these large language models. So this is the first part. Now second thing which we also talked about is that if you are using a base model, you can at any point fine tune it, right? And what do we mean by fine tuning? When we say base model, what does first base model means, right? Base model is nothing but storage of all the weights which we have utilized, right? So we talked about that these models have already been trained on a huge data set which is available on internet, and because it has already been trained, we need not have to train it again. So we just store those weights, and then those weights are made available for us, right? But when you talk about fine tuning, right, just to give you example of why you need a fine tuning, suppose you are working with a model which has been trained on a internet data, so, right? So it will very well predict, like if you ask who is prime minister of India, it will tell you because it is easily available on Google, right? Now suppose I'm a very spiritual person, right, and I ask it something very spiritual, which the model might have not learned through, right? Or might be the text which has been used in order to train that model is not there, right? But because I have to ask some spiritual question, might be I want a model to be developed for my organization, and then I want to take this base model because it has already been trained onto the huge text, so I need not do it again. But I'll take this base model, and then I will train it again on, might be text which is available for me, the spiritual text which is available for me, and then I will ask the model to answer my questions, right? This is just an example, but you can extend it, like fine tuning can be done for banking text, or it can be done on, yeah, we talked about medical, or for any, you have retail. If you have to do some kind of recommendation engine, then retail data can be used in order to fine tune the base models, right? So when you do fine tuning of the model, there are two ways. If you see the picture, it talks about prompt design, which we already talked about in the previous slide. But there are two ways by which you can fine tune your model. The first picture here, it talks about parameter efficient tuning, which is actually PEFT, which actually talks about that if you are using a base model, you freeze your weights then and there. So anything and everything which the model has already learned will not be overwritten by what I am training on. So you freeze your model weights, and then you train on the extra information. Like suppose I have a knowledge repository, then I train on it, and whatever extra weights I have, I will just club it through, right? So this is what PEFT is, where it freezes the base model weights, and then on top of it, it gets its own weights, which freezes together and work through. But the last picture here, it also talks about fine tuning, where it says that if you have to train it entirely from the scratch, and that's why I gave you in the top Bloomberg GPT, right? Bloomberg GPT is one of the app which Bloomberg has come up through, where they didn't use any of the base model which is available in the market, but they have used financial data, and of course it can be done only by the people who have such amount of data. So Bloomberg had rich amount of financial data, so they have used their own repository, and they have come up with Bloomberg GPT, which is basically a financial based app where you can question through many of the financial related queries, right? With that, we will go to the next thing, which is RLHF. This is third way of redefining or customizing your base model. So we already talked about fine tuning, but what happens in fine tuning is, every time when you fine tune the model, right, the model, you can expect different type of responses, different type of completions from the model. The example which is at the bottom, it shows you a prompt. The prompt read as, my house is too hot, and then because I have fine tuned it, might be I have fine tuned with different type of models and different type of weights, then every time you can see that there are different type of completions coming, and for that matter, this example is providing you three different completions, right? Now which of this completion is actually effective for us, that can be ranked by human, right? Because as a human, we understand which completion is actually more effective for us. So that's why it is human feedback, where the human annotators, they are actually made to go through all the completions which the model is providing, and then they rank those completions based on the priority which they think that it is more effective, one being the most effective, and then two, and then three. This is just an example, but you can have as many completions as the model can produce, and then human can actually rank, human as in person, you have to actually rank through the completions. uh, the whole theory about it is, once it has been ranked through, and once you know which completion is more effective, then that feedback, that human feedback, has to go back, and then it has to be clubbed into the weights of the large language models. And that's why it is called reinforcement learning using human feedback, where the human feedbacks are actually input back to the model in order to again optimize the weight, or more, you have to tune the weight more in order to have more effective or more accurate models. uh, we talked about three things, right? And we talked about the base, using the base model in a three different ways, which is prompt engineering, and then fine tuning, and then RLHF. But here, what I want to talk about is when you are using generative AI, right? It is very important to understand that how effectively we are using the whole infrastructure, or how you can develop this framework very easily, because nowadays compute is also very, the whole framework can be developed. But when as a person, that's when it is very important that we use this ethically, or we are very develop infrastructure about the responsibility of how to use this AI frameworks in a very effective way. So we call it HHH, and I'll go through some of the example. The first example here, it shows, it says knock knock, and the answer is clap clap. So you have to think whether this answer is actually helpful. If it is not, then you have to really think that whether you need to do some modification in your model. The second one is, can coughing effectively stop a heart attack? And it says coughing can help stop a heart attack. Is it an honest answer? And the third one is, how can I hack my neighbor's Wi-Fi? And the answer is, here are the best ways to hack. So, but it is not, is it a harmless answer? So that is what is called HHH. And these questions you should ask when you are developing any kind of generative AI. And based on this HHH, each different organization have different infrastructure, different definitions of responsible AI which has been laid. If I work for JPMorgan, so JPMorgan have their own ethics and their principles which talks about responsible AI. Google defined it differently, Microsoft defined it differently, but the picture here, it actually summarizes into two things. One is the ethics, whether you are really fine following the ethics of using the AI effectively. And it should be very inclusive, where you take into consideration the sentiments of a wider, you have to be very very considerate about considering the sentiments of the wider group, rather than customizing it for a smaller set of people. And the second thing is about explainable. So when these models can do wonder, but can your model can be explainable is something you have to be considerate of. So here again in this picture, we talks about several limitations and several risks which has been associated with them. But primarily, I will talk about three things here. One is toxicity, which we talked about, right? Which is kind of extension of HHH. If your model is not generating text, which is helpful, or which is respectful, then we have to be very responsible about how we handle the model. The second thing is about hallucination. We talked about that this model has been trained on huge amount of data, right? So sometimes it happens that the model has not been trained on something which we ask the question for, but because it has been trained on multiple other things, it will make up those answers and will answer you something which might not be the correct answer. But it will be something which the model has learned through, and it feels that it might be the correct answer. So in that case, if the model is hallucinating, then it might require more fine tuning or more concentration. And the last thing is about use of intellectual properties, that we have to be very considerate, specifically because these are trained on huge amount of data from internet, so we should not misuse any of the intellectual property. I will talk about some of the use cases which I have primarily came across many of the banking industry. Uh, the best example I can give is about Morgan Stanley. Morgan Stanley recently came up with one of the tool which actually present a chatbot. So they had a lot of documents. They have a lot of proprietary documents which they have for their employees. Now if an employee has to search through these documents, right, it takes a lot of amount of effort, or might be you have to involve an operator who is skilled to search through these documents, and they give you the result back. Your documents can be in SharePoints, in Confluences, might be in databases, and might be in scattered databases, right? And then you want to fetch that information. So it is actually a very tedious task. You can fetch the information, but it is actually a tedious task. So Morgan Stanley actually recently, you should read it, they came up with a tool which is kind of a chatbot where you ask for a particular information, and it has actually trained it on its own private repository, and it give you some information which is very relevant to what you are asking for by scanning through its huge repository. And the second use case which I want to talk about is generation of the SQL queries. That is again something which is of high importance, specifically in banking. When we work in banking, most of our database are legacy databases. When I say legacy databases, these are databases which are not primarily the advanced version of, when you say databases, right, you primarily start with cloud these days, where you have very advanced way of storing the data. But when I say legacy, you have databases like Teradata or DB2, or might be many other versions which are still not relevant. You are not, but then those still exist, right? So when you go through different databases which are relevant, and you want to query through those databases, right? Although all of them are SQL queries, but there is a variation of the format which the SQL follows from one database to another, right? So the SQL query which might work for Oracle will not be the exact replica which you can run also on, say, MySQL, right? So that variation, that's what the model is. So model says that you don't expose me the data, because data are very sensitive. So you just expose me to your metadata. As soon as you feed the metadata to the model can read through the metadata, and then it can actually generate you. So next time if you query on the large language model, that can you give me a query in order to fetch the name and age of my employees, then you need not have to create that SQL, but rather a SQL query can be created for you, because the model has already learned through the metadata which is available, right? Those are some of the use cases which I wanted to talk through, and this is the last part of my presentation today, where I primarily want to work on how AWS is. So AWS cloud is one of the primary cloud I have been working through in my career, and some of the best things which I found is what I have collected through. So the first is about Amazon Bedrock, which is very similar to, it is kind of a library which has been provided, and a interface where you can easily build and scale your generative AI applications. It is still in beta version, and there are a lot of innovations which are still going on, but it's very good place to explore through. The second one is about Amazon Titan. Amazon Titan is, we talked about lot of large language model which has been provided. So Amazon Titan has its own. It is AWS provided two large language model which is available, and we can utilize them for our model building. And we also talked about that want to use any of these large language model, you cannot do it without optimized compute, right? You need a compute which is very optimized, and that's why such a specialization of compute are easily available and can be tagged very easily to your compute devices in AWS cloud. And lastly, we talked about hardwares and the chipsets. So there are two chipsets which are available, which is Trinium and Inferentia. And you can see this data I have collected it from AWS site itself, where it says that if you tag these chipsets to your model as a hardware, then you can have a lot of cost saving, right, in the compute which you are performing to. So this is primarily my presentations today, and I hope I made some sense of what generative AI is and how we are utilizing it. With that, might be I'll request you, if you have any questions for me, you can please drop that questions for me in the chat box.
Hi, Supriya. Thank you.
Yeah.
It is like not just about one simple thing, right? It's generative AI. It's kind of a wide topic as well, and you rightly, put together from the start, like what are the evolution, where it speed up, like 2017, what happened before that, what we were doing 2014, like the evolution and what we are doing now, and also the primary concept of prompt engineering and then fine tuning. Those are really good. And definitely with the hype on generative AI, and this is the first session for Coimbatore group, and also this is hosted for across India, right? uh, we have like a lot of tools available, like you mentioned, triple H, and also like responsible AI. So those are the things that may not be easily covered. So those are the things that you rightly gave an example. So I appreciate that. Right now, like I will wait for another maybe few minutes if any questions that comes up. And one question I have is like hallucination. So can you give any additional example, like what does that mean?
Surely, I like to give my own model. So, my model, the base model which I have used, is something related to banking, right? But I have not trained it on my own model, which I want to use for my own chatbot. I'm building up a chatbot. But although my model is not trained on something, suppose I want to ask, how will you suppose I'm working on a credit card, right? I'm a credit card employee. I work on a credit card in a banking, and I'm building up a chatbot on credit card, right? So I have a lot of documents which actually talk about how to get a customer onboarded on credit card into the bank, right? I want to know that process, and because the documents are huge, I am building up a chatbot so that I quickly ask the chatbot, and chatbot actually points me to the correct document. So even if you take a base model, right, and you have not trained it through any of your documents, the model will actually try to build it up. As soon as you say, how will you onboard a customer on a credit card platform, right? It will actually build up your answer from whatever it has learned through, which might not be the direct uh, thing, the direct answer of what I'm asking through. And that is what is hallucination, and that's why prompt engineering actually plays a very effective role. So if in prompt engineering you mention this statement, it's very tricky thing to do, but I have tried it myself. So if you say that in the guideline, if you mention that if you don't know the answer, say you don't know, it will actually come up saying that I don't know. But unless you
Oh,
mention it explicitly, it will hallucinate. It will learn through whatever it has learned through it up. It will make up your answer and it will come back. So that's what is hallucination. And if it is hallucinating, we have to be very considerate about whether, and that's why the metrics which we use in order to measure these generative AI model, there are a lot of metrics which has been launched through. We have to be very particular about whether those metrics, the answer which is coming through, is actually effective or not. That has to be
okay,
measured through.
nice. Thank you for that. And one thing about I recently attended one of the conference on AWS generative AI. So the general question came up is like this Bedrock or any API driven AI services. How safe is our data? Like, do we have a data privacy? Is my data sold out or consumed by any other, shared systems, right? Especially serverless technologies runs on the same machine but isolated way. People are a little not so happy with that, like, or maybe not clear with that. So, how do you see when it comes like AI service, like maybe AI as a service, or maybe this LLMs as a service? Like, how do you feel like how it is going? Like, people ready to adapt, or
It is a very valid question, actually, Raghav, and thanks for bringing it up. Actually, when you talk about generative AI, right, now GPT-4 is in the market, but when as soon as a model comes, right, it is not made available for us. I will talk primarily about banking because banking is very sensitive with the data which we hold, right? So it is not only about using these models, but I think developing a framework around it. So you have to use such kind of model, right, you have to go with the compliance and the procedures which the banking is laying down. So before the organization make this available for you, if I have to build up a chatbot on an open AI system on my own machine, it will be a very different process. But if I have to replicate the same thing in my organization, it will be a totally different process, because I should follow through that compliance in the framework. And I think all organization is laying it through that before they are making us available, exposing us to this platform. They're making sure that the underlying compliance is well laid off.
Yeah.
Yeah.
Yeah. I think I understand this. When it comes as the platform perspective, it is always safe and secure. The privacy is in place, responsible AI is in place. So we just no need to worry about all that, since it is deployed in the cloud, like Amazon cloud, then it is always taken care. And before they release even to the public, it is made sure review generally like before make it generally available. Like there are a lot of tons of like work done behind that. So yeah, I think hope people start get used to this. Titan is the one which Amazon provides, and also Bedrock. They can try out multiple instances of different products. Thanks for taking questions. And I have one question. I'd like to show it on the screen. So I had a question from Vijay Rakun. Like I had used Amazon Comprehend API. Is it also using LLM models at the backend to categorize the sentiment of text?
I'll say I have not used Amazon Comprehend. I'm very sorry for this. So I will not try to make any comment here, because I have
Okay.
not personally used Comprehend API. But surely we should look back and check through that.
Yeah.
No comments. Yeah.
Okay. I have used Comprehend before, but definitely uh, part of LLMs, sorry, NLP, and maybe mix of some of these models might have been kept in the background. But maybe the generative AI, we are deep diving more because of this new thing. Comprehend and similar other products were not explained in detail. And Comprehend is a service where you have to do your own it's not just prompt engineering. You have to build your application using Comprehend. So that could be the other reason. It is an available framework that you can build for your application. Yeah, definitely some concepts might be used, and NLP is one of them. But LLMs, I don't know whether they have used LLMs on Comprehend. Yeah, that's a nice question. We'll definitely look back and see where LLMs might have been used, but it was not, so much brought into the limelight. We'll definitely in the future sessions we'll see where we can connect. Right. Thank you, Vijay for actively asking questions. And yeah, I think we are on top of the hour, and I would like to thank Supriya for taking your time on a weekend and presenting a depth of the concept. And I could definitely see most of the slides were like in depth. It's not talking about just the products available. It was like more clarity, and I think now so many like available learning materials are available, but the slides that you have shown has some more in-depth perspective, I would say. Thanks for that, and thank you for helping our community to learn as well. And yeah, any few words you would like to share it to our community from Coimbatore?
I wish you all the best, and you are doing a great, you're doing a great work, Raghav, collecting all us first and providing us the platform. I'll just say that I should thank you to you provide this platform for me to talk through, and it was my great pleasure when you collect through and then you speak through. I think it's more of a self learning which you also develop through. So thank you for providing me this platform, and thank
Okay.
you. Have a great day ahead.
Thank you, Supriya. And yeah, so now it's time we can look back on serverless topic. And I would like to welcome Srishit. Or he no need any introduction, but definitely is a popular person in the community. And I'm very happy to bring Srishit for AWS community Coimbatore for the first time. And I had a pleasure working with him for multiple events, like as a speaker manager, and also like a part of a community last year virtual edition. And he holds like a lot of enthusiasm on the serverless. And definitely if you are watching Coimbatore, follow AWS user Tripati, because he is running so many serverless topics there. And I welcome Srishit. Srishit, he's a head of technology at Conflub. and that company is really supporting AWS community throughout India, pan India, in many ways, especially on platform providing running behind this community days and all the recently we used quiz in our in-person meetup in Coimbatore. Everything was we implemented through Confab, and thanks for all the support. And hi, Shushit, over to you. I think you are on mute.
Yes. Hi, Raghav. Thank you so much, first of all, for having me here, and a very nice, humble introduction. Thank you so much for that. And I would like to start by saying Vanakkam Coimbatore. So I'm so glad to be here for the first time, and I hope it continues for many more sessions.
Sure, thank you. Yeah, so with that pleasure, I give it to you. You can start your session. Thank you.
Yes, thank you. I hope my screen is visible. Yes. Okay, great. Hello everybody, and welcome once again to this session on Gen AI and Serverless by AWS User Group Coimbatore. I hope you guys are all having a nice time with a very informative talk on generative AI in the first talk. And today I'll be talking about step functions, and the session's title is Stepping into Step Functions, right? So how many of you here have already used step functions, heard of it, used it for your just playing around, used it in production, messed up? Just let us know in the comment section. Of course, this is a online session, so can't really see how you are interacting. So the comment section is the best place for us to understand your points. So yeah, if you have any questions, please do feel free to post it in the chat box, and we'll try to answer as many as possible. So before I begin, a little bit about myself. I am Srishit Repakula. I'm an AWS Serverless hero. I work as the head of engineering at Confab. As Raghav mentioned, we are into the events domain where we help organizers and organizations host events, and we have a bunch of platforms, tools to help and ease out the entire process of event management. And I also am the lead for the user group Tirupati and host Serverless Saturdays. So first, I wanted to mention that when we talk about serverless, especially for people who are getting started, the perception is that serverless just means Lambda functions, right? But is that the case? Absolutely not. So when it comes to serverless, it's not just Lambda functions, but there are so many other services out there on AWS itself, right? I'm just talking, of course, about AWS. And these days, every single cloud provider, you name it, has a serverless offering. And it's not just cloud providers anymore, right? So you have Cloudflare Workers, Netlify has its own, this one. Vercel has its own edge functions. So it's basically available everywhere. So it is not just about your compute where you are able to run your code on demand. Of course, this session I'll not be talking about what is serverless, advantages, pros and cons. I'm not going to be touching about that, but rather I'm going to talk about one of the serverless services, which is AWS Step Functions. So we are going to cover about the various concepts that and features that AWS Step Function offers, and we will talk about a few of real world use cases where, for example, from Confab itself, where we have used step functions and how it has helped us in achieving a few things that was relatively more complex if we had to take the traditional approach. The first thing I want to mention is it's not just Lambda functions. You do have a lot of other AWS services that are serverless as well, of which we will cover step functions today. So first of all, what is a step function? A step function is a pay-as-you-go service, which means that you only pay for how much you consume. It is a completely serverless service which can scale. Of course, there are going to be limitations in terms of concurrency, number of executions, and all those things, like data size limit. We will be talking about a few of those along the talk, but Okay, but what is step function? Step function is an orchestration tool which you can kind of design a workflow where you can mention that you have lambda function A, and once lambda function A is executed, I want to execute lambda function B. And after B is executed, depending on the result of D, I want to decide whether I want to execute C or I want to execute D. So essentially, you're kind of configuring a workflow for your operation or for your flow, so that you kind of create a state. As again, if you guys have used serverless, then you might of course know that it is a completely stateless service, right? So where you can't really maintain the state from one execution to another. Now, step functions kind of can provide you a mechanism to maintain a state from one lambda function to another, and help you design and build a workflow. So it is a fully managed service on AWS, which means that you don't have to provision anything, you don't have to do anything. All you have to do is create a step function, which we will see in action in just a bit, and you just have to run and execute it. And as it is a serverless service, the pricing is pay as you go, which means that you will be charged based on the number of executions that you have. There are a few more nitty-gritty details when it comes to pricing, which we'll try to cover in the upcoming few slides. The other few important standout features of step functions, if you ask me, is the built-in error handling. Again, we will be diving a little deep into how we can do error handling, retries, and all those things with step function. And the other a beautiful capability of step function is its ability to integrate with over 200 other AWS services. So step functions is not about, okay, I'll just have a workflow that can help me organize or orchestrate lambda functions. No, that is not the case. You can easily integrate it to almost 200 AWS services, of which we'll be talking about one of it. We'll try to do a direct integration with DynamoDB, and we will see how it is. First of all, a few key concepts, terminologies, if you may. The first one is called as a task. So there's tasks, there's state machines, integrations, error handling, and monitoring. So a few key concepts, right? So task is basically all the work that you do in one state. So in a step function, again, we'll see how you can configure a step function and what are the things that goes into the configuration. By the way, it is you write the step function configuration using JSON-like syntax called as ASL. Again, we will be touching upon that as well. We will see how the format looks like, what are the various keys and what do they mean, and how do you configure them. We will be looking into that as well. So a step function, there are multiple steps, which is what we have, and over there you have tasks, right? So which is basically the work that you do, like what you want to do. You want to invoke a lambda function, you want to do get an item from DynamoDB and stuff like that. Then you have state machines. State machines are basically the states are elements in your state machine, right? In the each state of the state machine, which is what we will be configuring for a step function, is called as a state. And then you have integrations. As I mentioned, you can directly integrate over 200 AWS services. Error handling, which we just talked. You can have retries, exponential backoff, everything out of the box. Again, the exponential backoff also is something that we will see in the demo. And you can use monitoring. You can use AWS Amazon CloudWatch, which directly natively integrates with step functions. Again, we'll try to look into that. And we'll also very briefly cover about another observability tool that can help you easily monitor your serverless applications in general, but in this case, of course, as step functions. It is called as CloudMate. So we will be very briefly touching about and see how it can help you monitor your step functions and serverless applications in general. So a few things, the terminologies. What we have as a task is a single unit of work. Then we have choice. This is something that we will see. So what is a choice? Is basically a state where you can decide what way the next step should be, right? So depending on a condition or a set of conditions, you can decide which branch should the flow take next. Then we have parallel. So in parallel, what we do is we can execute multiple steps in parallel for an array of inputs, right? Just like a for loop in terms, right? So then we have fail, wait, succeed, and pass. So these are a few states that is available. Wait being a delay for a specified time. Now, let us imagine a scenario where you have a lambda function, and its purpose is to call call a third-party API, and you kind of have to give some time for the third-party API to complete its processing, wait for some time, and then check back on the status, right? So if you have to implement, we can implement in the code Python, Node.js, or Go, whichever language you're comfortable in. What you can do is you can trigger an API call, wait for a few seconds, and then check back on the particular API endpoint to see if it's ready, whatever it has to do, the processing part, right? So instead of doing this inside the lambda function, we can do the entire wait part outside, move it out of the lambda function, break it down into two lambda functions. One is to call the API and then wait in the step function, and then the next step is to just call and check whether the particular processing is completed or not, right? A simple example is like a reporting tool where you have to call the database or inform a third party API that, okay, I want to generate a report for the last 6 months, right? Now it's going to take a few seconds, if not minutes, right? So they will take some time to generate the report, whatever third party tool. So you kind of wait on the API to be completed. Instead of waiting in the lambda function, you can move it out. So what is the advantage? The first advantage is, if you wait, of course, every programming language has the capability to add a timer, you can stop it and stuff like that, sleep, all those things are possible, right? So one of the advantages is, if you have the sleep in your lambda function itself, in your code, it means that you are waiting and the lambda function is still executing, right? Which means that you will have to pay for AWS for the entire execution time, right? Irrespective of, let's say you wait for 1 minute, then you have to pay for 1 minute unnecessarily to Lambda service, right? Instead, you move this wait time out into step function, and you don't have to pay that extra cost from the Lambda perspective. And then you have the fail, succeed, and pass states. So depending on whether you want to fail the step function, succeed the step function, or pass a particular input to the next state, you can decide to use those states as well. So let's proceed further. I would like to start with a very basic, trivial example of generating or how you can migrate to step functions. Of course, this would not be a real world scenario, but this is just a very basic example so that all of you can understand what is the advantages of step function and how you can kind of migrate it. So here we have a simple example where we have a Lambda function code which talks to DynamoDB and queries the data from DynamoDB table, right? Imagine you have an API integrated to it. So you have an API that calls a Lambda function that talks to DynamoDB and fetches the data from DynamoDB to you, right? So actually, let me share my entire screen and let us try and create a step function and see how you can migrate the flow itself. I hope my screen is visible. Right. So as I've mentioned, the Lambda function is very simple. So what I have is I have created this Lambda function, and I hope it is visible, readable. So it is kind of very straightforward. So what we have is, it's written in basic Python. I mean, even if you don't know Python, it's basically what we are doing is we are creating a resource for DynamoDB using Boto3, which is the SDK for interacting with AWS services in Python. And you have a Lambda handler. So what we are doing is we are simply performing a get item on the particular table. So I have a DynamoDB table that I have already created. Let me just refresh this. Okay, let me just do one thing. We'll just delete this. I'll tell you why in a minute. Yeah, so we have one record here. right? So we have one record, and it is foo, and it says developer is the job title. Very simple, very trivial, right? So what I'm going to do here is I have a Lambda function that is performing an operation to fetch the details from my database. Here in this case is DynamoDB, right? So let us quickly kind of test it out. So I'll just pass on an input, let's say foo, and I will say save, and I'm going to test it, right? So as you can see, I got the response from my Lambda function, right? Simple, straightforward, nothing here, right? One thing that you will have to understand, again, if you have played around with Lambda functions and used it in production for some time now, you will understand that a good number of scenarios, all we do with Lambda functions is transforming and transporting data from one point to another. Like, say, for example, we have an order managing system. Again, I'm taking very simple examples. Of course, they might not be directly related, these ones, into the real world production applications, but just to give you a perspective and an idea of how we can achieve this. Of course, towards the very end, I will walk you through a real life production step function kind of complex and show you what happens over there, right? With all these features that we are going to talk at a very, very granular, small level, right? So let's say you have an application order management system where all you do is you accept orders. In accepting orders, all you do is just go and write it to DynamoDB, and then you have a page where you can list all the orders, and a page to update the order, all kind of CRUD operations that can be possible, right? So this is, imagine this is one API to fetch the details from the database. In this case, like an employee management system, where given a particular employee ID, I'll get the job title, right? So we have a Lambda function, API gateway is attached, everything is simple and straightforward. Now, as a very first step, as introduction to step functions, I want to show you how we can integrate or create a very basic step function, and how we can get rid of this Lambda function and directly talk to DynamoDB and fetch the details using step functions. Okay, so what I'm going to do is I am going to go to step functions. So yeah, so kind of this is what we are going to kind of build it. So yeah, I mean, I kind of jumped into the demo time. I hope the demo cards are with me, and hope it kind of works, right? So when you create a state machine, so that is what we discussed, right? So you define your workflow in a state machine, and here you have three options: design your workflow visually, write your workflow in code, and run a sample project. I'm just going to say design your workflow visually. I'll show you what it means by visually. And there are two types here, as you can observe. One is standard and the other one is express. What is the difference between the two? What is standard? What is express? We will cover that in a bit. For now, let us just go ahead and proceed further. Now, this is what is called as the workflow studio, right? So because I chose an option where I wanted to create the state machine visually, that's why you can kind of see this entire diagram of sorts, where you can define your own step function. So on the left hand side, you can kind of choose what actions you want to do. There's something called actions, flow, patterns. There's so many options available, and as you can see here, as I mentioned, you can directly integrate over 200 AWS services. As you can see, so many of them are available here. All right, so what I want to do, our use case is to simply fetch data from DynamoDB, and we are trying to get rid of a Lambda function. So what I will do, I'll simply go ahead and search for DynamoDB, and what I want to do, I want to perform a get item, right? So I just drag and drop that particular state here, and now you can see on the right hand side the definition of the particular state, right? So here we have to perform the API parameter. So you can define a name. So get employee, let's say this is the name of my state. Okay, you can see get employee, it is of type DynamoDB get item. Integration type optimized, just leave it alone for now. Then this is the API parameters. So what are the list of parameters that step function needs to call DynamoDB get item? Now, again, assuming that you have a very basic understanding of how DynamoDB works, it's a NoSQL database where you can query data from DynamoDB using the partition key, right? I'm not going to get into the details of what is a key, primary key, partition key, sort key, all those things, but all you need to understand is you can use a key to fetch the details, right? So here we have to configure what is the name of my DynamoDB table. Let me just go here. This is a random DynamoDB table that I had created. I'm going to replace it here, right? And key. What is the partition key for this particular table? It is actually employee ID. So I'm just going to say column employee ID is equivalent to a string data type, where I'll tell you what is dollar in just a second. So here dollar dot employee. So you are trying to configure a step function. Of course, the input should be dynamic, right? So when you say dollar dot employee, it means dollar here means the input that is being passed to the Lambda function. Sorry, step function in this case, right? So you are passing an employee to the step function as the input, and now in the input you are referencing a key called employee. So that is what we will be passing it to step function. As simple as that. So what we are doing is, again, if you use have used DynamoDB, you would do exactly same thing. Actually, you can go here. We can see here in the code what we are saying: get item key employee ID is equivalent to event of employee. So whatever is there in the input, I'm going to fetch that and pass that as the employee ID, right? So let me just go here, and we have dollar dot employee ID. So here S means it's a string, so you kind of define what data type that you're calling. So I'm just going to leave everything as is, and let's say I click on next. Now, in the next step, this is where you can see that ASL, which is Amazon States Language. It is in the form of a JSON. The syntax and everything is a JSON. And here you can see I have, my state starts at get employee. And this is the states, the definition of get employee. Over here, you will see the definition of the particular state. A state is where you can kind of do your task, right? Or your work. So here it's of type task. Now, what is the resource? It's going to be a DynamoDB get item. So that is the resource. And what are the parameters? We have the table name. We have the key that is used to query the data, with employee coming from the input of the step function. So I'm just going to leave this as is, and this is a pictorial representation of the graph. And I'm going to click on next. And I'm going to create a new role. I'm just going to leave everything as is for now. And let me just say, this is just for logging. So it's going to create a new CloudWatch log group for me. And I will just go ahead and create a step function. It's going to just take a few seconds. So in the meantime, if anybody has any questions, please feel free to post in the chat section. Okay, cool. So now we have created our first state machine, right? So you can see here, you can see the details. It's type standard. Again, just give a few more minutes. We will talk about what is standard and what is express. And you have the list of executions that you see here, logging. You can see the definition of the step function. What is the definition? Aliases, versions, and tags. Right, so aliases and versions, again, I'll not be covering in depth in this. Again, if you have used Lambda functions, the same thing applies here. You have aliases and versions, so you can kind of create multiple versions of your state machine and have aliases to those versions. So you can have a production ready version as an alias, which is properly tested, properly configured, and then you can have a dev one, you can have a a work in progress one. All those things kind of helps you maintain multiple versions of the configuration of your step function, right? Let me start an execution. A name, this is optional, of course, but it'll just pick up a random UUID. So here I'm going to pass foo, because that is what we have here. I hope it works. Fingers crossed. Okay, it was successful. That is good to know. Now, if you can see here, it didn't even take a second, right, for it to complete. Of course, very trivial. All it's doing is basically fetch the details from DynamoDB, a basic get item operation, right? So in this case, we have only one step. So that is why you see, you'll be able to click on one step. And here you can see the input, the output, the details of the particular task. How long did it take? At what time did it start? How long did it take? The definition of the particular state in this case, and then the events. So if you further scroll down, you can see like a trail of events that have happened. See, you have execution started, task state entered, task state schedule, task started. So all these things is what is kind of happening over when we do execution, right? Now, let me show you the output. So in the output, you can see item, employee ID, foo, and job title as developer, which is what we got directly from DynamoDB. So it kind of works, right? So very simple, very trivial, nothing complex, nothing fancy. The thing that we achieved right now is basically the fact that I have removed a Lambda function from my execution, from my entire workflow. Now, what is the advantage of that? I can have a Lambda function. I have better control over what I can do in a Lambda function, right? I mean, you can do almost anything in your Lambda function because you can write your own code, you can have your own business logic and everything. Absolutely, yes, true, right? So there are certain scenarios, as I mentioned, where we leverage Lambda functions just for transporting data or transforming data from one point to another. Like, for example, you receive a new employee, is created. All you want to do is just go ahead and insert into DynamoDB. Do you need a Lambda function in such scenarios? Maybe not. But there will be a certain scenarios where you will need a Lambda function, and that is unavoidable. You need to have a compute where you can write your custom code, use some dependencies, modules, add some validations, and all sorts of things, right? So in those scenarios, of course, we will have to go to the Lambda function. Now, what is the advantage? The number one advantage is you have one less component in your architecture, right? So the lesser number of components, the lesser cost, isn't it? So irrespective of whether I am using a Lambda function to fetch the details or directly calling DynamoDB though I have to pay, right? But at least Lambda function I'm kind of reducing it. See, again, if you have played around with step functions, you can always come back at me saying that I am paying for step functions execution cost, right? Yes, that is true. In this case, you are paying for the step functions execution cost, and if you go with one of the standard types, it's actually much more costlier, right? So the entire pricing debate, we will do it in just a bit. Again, I'm just trying to get you started, all of you, into step functions, how to generate, what are the basic features and everything, right? So yes, now we have created the employee, it is working fine. Now, what is the output that we want? We want an output saying that employee ID is foo and job title as developer. I don't really want so much, right? So that is first thing. Second thing is, what will happen? Let's say I create a new execution and I say bar, right? So what's going to happen? It says successful because ideally, I mean, we are not doing anything, right? If you look at it in the previous execution, we had an object called item here, but that item is no more here, right? Because we are not really leveraging the data. All it's doing is executing, right? You can perform a get operation on DynamoDB for a data that is not even present. So it will not throw any error. So what is the next step that we'll have to do? Is we'll have to read the data from this state so that I can pass it as an output. So I don't want this as the output, right? So this is the output that is coming from DynamoDB. This is of no use for me nor for my application. So how do I manipulate that? So let's go to the edit state machine, and I'll go back to the workflow studio here, where we can visually configure. Of course, if once you're comfortable, you can kind of configure it in JSON directly, once you're comfortable with the syntax and everything, right? So what I'm going to do here is, this is where I want to introduce something called as the choice state. Okay, so we have the choice state, which is a simple if-else condition, like I said before. You can configure a rule, and depending on that rule, you can define whether I want to go to this branch or I want to go to this branch. Okay, so let me just go here. Rule one, I'll add a condition. So yes, this is the case, dollar dot item. So as I mentioned, dollar is like the input, right? The input that is passed to the current state. Now, my previous state was get item from get item, I got the data from DynamoDB, and it should have a key called item. Now, if it is present, then it is a success, right? So what I want to do, I want to, let's say for example, pass the output. Okay, so it's a pass state. So let me go back here, and here in this rule, whenever the data is present, then I want to go to the pass state. Okay, now the next condition is okay, now this is done. Let me add a new choice, or rather let me edit the default itself. So let me just remove this, and in the default, yeah, sorry, yeah, now let me close this also. You have if it is present. Now the next one is if it is not present, right? So dollar dot item is not present, then what should I do? I want to fail my state. Okay. I hope this is clear. So what we are doing is we are fetching data from DynamoDB and deciding on whether the data has been fetched or not. I want to pass and succeed, or I want to fail. All right. So we have the choice state here. We'll have the input and we have the output. Okay, so in the pass state, so what I will do here, I'll have the input that is passed from here, and in the output, as I mentioned, I don't want the entire data that DynamoDB is giving me, right? So I just want specific parts of it. I don't want the entire JSON with HTTP headers, keep alive, and all those things, right? So what I'm going to do, I'm going to extract. So the employee ID will be dollar dot item dot employee ID dot s. Okay. So again, if you're familiar with the DynamoDB syntax, this should be a very straightforward thing. Job title and job title. Okay, so let me apply and exit. Now you can see the configuration. So you see the diagram got updated, and here you can see we have get employee, choice state, pass or fail. In the choice, we have if the dollar dot item is present, then it will go to the pass state. The pass state is configured here. Over there, we have the result that we want to return, where employee ID is dollar dot item dot employee ID dot s. Okay, let me save this and start a new execution. Okay, so we have employee and then okay, start execution. Okay, it is successful because the data was there. You go here and you see this is the output. Right, so if you want to see the input and output of the step function itself, which is a state machine, I passed employee foo as the input, and you can see the output like this. Okay, now yes, one thing here, you might have observed that it came exactly like this, which is wrong. I actually want to reference a variable, right? So what I will do, because my configuration was mistake, so I have to put dot dollar here. So this is a bit of a syntax that you'll have to learn. So let us start a new execution. Employee. Start the execution. Where is that? Okay, 1 second. Let me. I think I missed something here. 1 second. Yeah, this is what happens when you kind of try to do things in live. Actually, this is correct. Let me try and see what exactly was the mistake in my configuration. Edit. Input path, whatever is passed here, we get that. Let me just go back to my execution and try to look into this. So here you can see we have the choice state output is returning the employee ID, and here we have the input, the entire thing, and here dollar dot employee ID dot s. Yep, this is correct. Let me just again quickly cross check the configuration. I'm sure I missed something. Yeah, this is the same one that I had used. where is it here, right? Let me edit the state machine. Let me just try and replace the entire one here. Yeah. Got it. That was because of my. I'll tell you what exactly was the mistake over there. I hope this time it works. Some else mistake I am doing. Let me try and go back to the one that I just did before this one. So let me show you the difference. Actually, there's no difference per se. You can see here I have the pass state where I have type pass, and once that is successful, here we have the result, employee.dollar and job title, and here we have. So let me start a new execution. Yeah, I'm still. I guess there's some typo that I'm doing somewhere. Let me come back to this towards the end. But I hope you guys have understood the basic concept that I'm trying to share here of how you can integrate with DynamoDB and kind of fetch the details. Towards the end, I'm sure I'll try to figure out what exactly is the mistake that I'm doing here, and I'll help you with that. So this is the place where I wanted to show how you can integrate your choice state and directly integrate a step function with a lambda function, right? So this is the first thing, the choice state we discussed, the direct integration with AWS services we saw. Of course, integrating a step function with a lambda function is again a very straightforward thing. We don't have to kind of worry too much about that. It is straightforward. So like again, if you want to go here, let's say edit and edit in the workflow. So what you can do, if you want to have a lambda function in the middle, you can just keep dropping it, and you can have as many lambda functions as you want, and you can kind of design a workflow, right? So the next thing that I want to talk about is the map part. Okay, so let me just go back to the presentation, and yes, this is my current state. It's not working as how I was expecting, and rightly said, everything fails all the time, right? So it did my demo also. The last part didn't work as I expected. So I just wanted to talk about a few things. As I mentioned, we will be let me just get into the full screen mode, where I said I'll be talking about real world scenarios, right? So this is a basic, a high level architecture diagram of what we have in Confab for managing the entire ticketing service that we have, right? So basically, from our platform, we sell tickets and people buy tickets, right? So this is on a very high level what happens. There's a lot of components lying around. There's a lot of services that are involved, and as you can see, it kind of is messed up in terms of the number of communications that is happening. You see so many arrows and stuff that's going here and around, right? So now, on a high level, if I have to put it in something that is more understandable, is here you can see there are a few high level components. You have the checkout service, you have payments, you have app data, event and registration, and user management, right? At a high level, this is again a real world example of what we use in Confirm, right? So you have on a high level, you have these components. As you can see, they are interacting with each other. There's cross communication and everything, right? So how can we kind of reduce these tangles that is between this so much? So that is where step function comes and helps us orchestrate the entire workflow and make it much more simpler and easier for us to kind of configure the entire workflow, right? So this is again a high level example. This is not exactly what happens behind the scenes. There's a lot more components that is there. So what we have is I mean, it's as good as a book my show, right? Where you will be able to purchase multiple tickets, or an airlines, or an IRCTC, any kind of a ticketing platform, where what you do is you kind of buy tickets. Let's say, for example, I take IRCTC. Okay, where I buy two people two train tickets. Now there are two registration details in the input that I have to process, right? So what we have done is we have very minute components of lambda functions. Like you can see here, one lambda function is to store the details in the database, one to send an invoice, one to create a profile so that once they log in, they will be able to see all their tickets. Again, just for the sake of simplicity, I have kind of trimmed it down. But again, as I mentioned, there's so many components that happens behind the scenes in any real world application, right? So here what we do is we have the map state. Okay, so what is a map state? It can iterate over the inputs that is passed. Okay, and here what we do is, for every input, as I mentioned, let's say there are two tickets that I'm purchasing, it'll run in parallel for both the tickets. Okay, so depending on the ticket type, whether it's free or paid, because I don't have to send an invoice if it's a free ticket, right? Like a community event like this meetup, if you want to organize, right? It's a free event that anybody can come and participate, right? So depending on whether it's paid, free, or whether it's an in-person event, or all those things, there are some conditions that is applied to decide whether I have to send some ticket or some invoice or some other details. So that is where this comes up, and then we have the next step to add to the database, and then create a profile, and then we kind of done here. Right now, there's a common catch block here, which is a notify error. So again, what is a catch block? As I mentioned, one of the important features of step function is retries and error handling, right? So what we can do is we can have a catch block for the entire any specific. Also, I can say catch the error from this lambda function, and I want to handle it differently, right? So there are some scenarios like that that can be handled. And if anything fails here, I have a common catch block, and independent services also can have its own catch blocks or retries, so that they can implement how they want to implement, right? So that is on a high level, what how we kind of untangled this one into a much more cleaner, visually representable workflow, where imagine this is so easy for anybody to understand. Okay, from here I have to go here, and if this is what we get, I have to go here. It's much more easier for someone new to understand, right? It's a visual representation of the entire flow, right? So if you have worked with stuff, serverless applications, you know that there is just so many components out there in your application. You have API gateway, you have a lambda function, you have SQS, you have SNS, DynamoDB, RDS, Cognito, I mean, whatnot, right? So especially in serverless applications, you tend to consume a lot more AWS services than a traditional architecture, right? I mean, that is one of the advantages, if you ask me. So you have too many components lying out there, too many things that are not probably directly talking to each other, so it's very difficult to analyze. It is very difficult to understand the flow from one piece to another. Distributed systems, right? So this step functions kind of help you have a more visualized way of designing your entire workflow, right? So that is what we have. And now, one of the things that I mentioned that we will be talking about is the standard versus the express workflows, right? So when you create a step function, it kind of asks you what kind you want, or what type you want to create the step function as. Is it a standard or is it an express, right? So how do you decide? So this is on a very high level on how you can decide. One is uh, depending on the amount of time your entire workflow needs for it to complete, right? So this is kind of very important, and this is the main factor for you to determine. Okay, so express workflows can only run for up to 5 minutes. Okay, if you have something that probably can or needs to take more than 5 minutes, you have to switch over to a standard workflow. So whenever you have something that is long lasting or takes a bit of a time, it has to be a standard workflow. So in Express, the maximum time limit is just 5 minutes, whereas in standard it can go up to 1 year, right? So your entire workflow can just wait or execute for as long as an year, right? And Express is cost effective. It's much more cheaper than standard, because standard comes up with a lot of other advantages, one being exactly once delivery, right? So whereas Express deliverability is at least once, right? So it means that when you're building your workflows using Express, you have to build for idempotency. So there is a possibility that your code might get triggered twice for the same input. So you'll have to build for idempotency, right? And in the standard workflows, it only supports exactly once, right? And Express is for short duration and high throughput, right? From a pricing standpoint, as I mentioned, standard workflows are much costlier in comparison to the Express workflows. So the as you can see on the left hand side is the standard, where you can see the number of the cost per thousand state transitions. So you kind of pay not only for the lambda function or the DynamoDB, you also have to pay for step functions, right? So here you will pay, as you can see, 0.025 for every 1,000 state transitions, right? Which is actually kind of costly in comparison when especially you have something at scale, right? Now on the right hand side, you can see what it is for the Express workflow, right? So Express workflow is similar to what a pricing for a lambda function is. It is dependent on the memory and the amount of time, right? The GB hours thing. So as you can see here, if you take a 64 MB and this is how much time it's going to take, it's going to cost this much for you. So it's much more cheaper than the standard Express workflow, right? There's one more thing that I wanted to mention here is the intrinsic functions. Again, if you guys remember, sometime back I was mentioning lambda functions, we a lot of times use it for transforming or transporting data, right? So intrinsic functions are some functions that can help you do some data manipulation within step functions itself. Like you can have arrays, JSON data manipulation, mathematical operations, string concatenation, UUID generation, stuff like that. You don't need a lambda function, right? Like for example, you have an order system, right? So every order needs an order ID. Now for that, I don't really need to have a UUID module. I can just simply leverage the intrinsic function that AWS has. A few of them I've just mentioned here. States.array, it creates an array with a given input. UUID, this is the one that I talked about, right? Universally unique identifier. So if you want to create an order ID, user ID, all those things, you can just simply leverage the intrinsic function itself, instead of having to go ahead and create a lambda function just for this, right? And there are a few more. So when do you use standard? So if you ask me, by default, start by thinking that you should use Express, right? So start trying to think about Express, and if that is not going to help you or that's not solving all of your use cases, then you can switch over to standard, right? Or how do I immediately decide, right? So if you have any task that takes more than 5 minutes, there's no option. You cannot go to Express. You'll have to switch over to standard. And if at all you have a scenario where you want to use something called as the callback pattern, this one we will see in live again. So what is a callback pattern? Is basically the capability for you to stop or rather pause your step function and wait for someone to come or something to come and trigger and resume it, right? We will see that in action. And the last one is requires exactly once execution, right? If you want something that is something you essentially want to make sure that it is exactly once execution, then you switch over to standard. Right. So this is on a high level. What is the callback pattern or the emit and wait pattern? So what happens here is again, in the interest of time, I'll not explain this. I'll show you the actual flow itself. And the other one. So there are two things that I wanted to show. One is the callback pattern, and the other one is the parallel state executions, right? So parallel invocations, what it does, it's basically executing a lot of independent workflows doing their own thing. So you have one workflow, second workflow, third workflow. They are doing all of things on their own, right? So basically what happens is the same configuration is executed with different inputs, right? And if one of the branches or the parallel executions fail, it doesn't kind of have an impact on the other because each of them are independent of the others, right? So the other one is we have a parallel state. So here what happens is you can, so one is the map state and the other one is the parallel state, right? So a parallel state is basically you want to execute multiple things in parallel, right? Let me give you an example of what we do in Confab itself, right? So whenever you try to register for an event, what we do is we kind of validate whether the email address and the phone number that you have provided are valid or not. Now, in this case, imagine the one way is this, where I can have validate the email address and then validate the phone number, or instead I can run them in parallel because they are not dependent on each other, and the same input is kind of passed to both of them. And once both of them are successful, you can do this. And here you can have errors for individual, and that kind of can determine the state of the entire step, right? So here I can say that if this fails, I want to fail the entire thing. So all those kinds of things can also be possible when you go to the parallel state. Then we have the dynamic parallelism. So here, what happens, this is where I wanted to talk about the map function, map state available from step functions, right? So here what you can do is you can have a sub workflow to accomplish work faster by using more resources at the same time, right? So here you have, again, let me show you that example. Yeah, okay. I'll show you that example once I cover this one. So a map state is like a for loop in your programming language, right? So you pass one input, but the code that is executed is the same. The input varies from one iteration to the other, right? That is what is a map state on a very simple terms, right? So we have two types of map states available in step function. One is the inline mode and the other one is the distributed mode. So how do you decide when to use what, right? So if you go with express, then the only option is inline mode. If you choose an express workflow, if you choose a standard workflow, then you can decide whether you want to go with inline or distributed. When do you choose what? See, what it does is the same, okay? So it kind of is a for loop sort of a thing. You pass an array of inputs, and for each input, it will execute the entire workflow for you, right? So there are a few limitations of inline mode. That is why the distributed mode came recently, a few months back, right? So what happens here is if you select the map state to run in the inline mode, then you have to pass the JSON array as the input to the state. Okay, so you have to pass the array itself. The problem with that is the size limitation. So there is a maximum limit of 256 KB for each input. Now, let's say you have a very large CSV that you want to process or store or migrate into a database, and each record is huge, then there's a high possibility that you will breach the 256 KB limit, right? Therefore, you cannot use the inline mode. You have to switch over to the distributed mode, right? And here the other implication is you can only run up to 40 iterations as concurrently as possible. So as I mentioned, map is like a for loop, right? So you can have multiple instances of the same workflow executed in parallel. So what happens is you can have at max 40, but here in the distributed mode, you can lets you run up to 10,000 parallel child workflow executions, right? So that means if you, let's say, for example, you are trying to import a CSV and trying to insert it into the database, you have like say 10,000 records. In the inline mode, it's only going to kind of be able to process 40 at a time, whereas here it can do 10,000 at a time. I mean, 10,000 child processes can come up, right? So very quickly, again, in the interest of time, let me show you something that I had already built. I have created something called as the bulk import, right? So what it is going to do, very simple. It will, we have seen the DynamoDB table that we have created here, right? So what I will do is I'll try to, import data into this DynamoDB table using step functions. A very simple example of how, or for you to understand how the map state works. Okay, let us quickly go to the workflow studio and see what the configuration or definition is like. Okay, so this is my step function. Again, very simple. So here I have a map state. You can simply search for map and you can kind of add it here. All right, so we have the map state. And what it is going to do is, you can see the definition here. Okay, so it's a map function. As I mentioned, there are two modes: inline mode or a distributed mode. So inline mode, you have to pass the JSON array as the input to the state, whereas in a distributed mode, you can pass a file from S3 also, right? Let's say, for example, you have exported the data from I don't know, RDS, right? Exported to S3. I'm just giving you a simple example, okay? You have somehow exported the data, or you are migrating, you have a SaaS platform, and your competitor, your customer has been using the competitor, wants to migrate into your application. So you have to, they export the data from the competitor platform and import the data into your platform, right? So let's say there's a JSON data or a CSV, both of them are supported, and they upload it to S3, and you can read the data from S3. I mean, step functions will read the data. You don't have to do it. I'll just show you that. So I'm going to use the distributed mode, and you can see the options, item source. So where is the data coming from? It's going to come from S3. Okay. It's a JSON file. And where is the data? I'm going to accept the bucket and the file name in the input to the state machine. Okay. So I will pass the input, and depending on this, step function will read the data from this file and iterate over and process this state. Okay. So once the map is done, so again, child execution type, what this is basically, I had created this bulk import as a standard workflow because I wanted to use the distributed mode. I just wanted to demo that, right? So if you create a express workflow, you will not even see this option. It's only going to be inline. Okay. Now, the advantage of one of the advantages of step functions, as you saw, right? Standard is costly, whereas express is much more cheaper. So one of the suggested practices is you can kind of mix both. It is not like that, okay, if a standard means I have to have everything inside also standard. So in this case, what happens is my outer step function is a standard workflow, whereas my map state, I want to run it as express, so that this becomes cheaper for me. Whereas the overall, so basically what I'm trying to do, or rather show you here, is I can mix and match standard and express workflows to kind of help me reduce the cost, improve my performance, improve my throughput, and all those things. Okay, so that is what this does. And once that is done, we push to the success state. Okay, so simple and straightforward, right? So in the DynamoDB, it's in the first example, we saw the get item. Here we are going to do the put item, right? So what we are doing, for every iteration of the JSON data from S3, we are going to perform a put item operation. So here the same DynamoDB table that I have given. Okay, and here I'm saying the employee ID is what is the, whatever is there in the input, dot employee ID. Job title is also whatever is there the input, that job title. Okay, so that is what we kind of have here. Now I hope this is clear, the definition. Right, let me just go back here and try to create a new execution. So this is my bucket name. So I've created a bucket, and I have created a simple JSON array file called bulk import. Let me quickly show you what is the data in that. So this is the data that is there in that file that I imported. So you have the employee ID, then you have the job title, and then there are multiple objects. I just kept it as 3, but of course, in real case scenario, it's just going to be quite a lot more. Okay, so I have started now the execution. I hope this time it works. So yeah, now it is successful. It took around 2-ish seconds for the entire thing to complete. Now you can go here to the map state, and you will be able to see what is the input, what is the output, and everything, right? So let us see whether it kind of inserted. Okay, good. So as you can see, the data that is there in the JSON file that I had imported or uploaded to S3 got converted, processed using the for loop or the map function, and got inserted into DynamoDB. All of this without a Lambda function. I didn't even read the data from S3, right? As you can see here, as I showed, all I did, where is that? It is here, right? All I did in my definition is tell step function where to read the data from. So if you see the JSON configuration, right? So we have a map state, okay? And here I'm saying the reader configuration is of type JSON. and it's going to be a get object from S3, and here's the bucket name and file name, which I will be passing as parameters to my state machine, right? And once this is successful, we're just gonna return success as the part. So as simple as that, I did a very simple migration of data from S3 into database without a single Lambda function, right? And the advantages, as I mentioned, you don't have to pay for Lambda functions, and the other advantage is the cold starts, right? One of the things that a lot of people do talk about when we talk about Lambda functions is the cold start, right? Now, if you don't have a Lambda function itself, there's no cold start, right? So this is the whole point of direct integrations, right? And and it's not just only step function can directly talk to DynamoDB. Even your API gateway can directly talk to your DynamoDB table without even needing a Lambda function. In fact, I once did a workshop where we built a very simple URL shortener. I'm sure you guys have used, right? Bitly, tiny URL, all of that without a single Lambda function. Everything API gateway directly talking to DynamoDB and stuff, right? So direct integrations, you try and see wherever it is possible to have it. Okay. So there's one last thing that I wanted to talk about is the callback pattern, which is again, this is the last one that I want to show a real world example. In fact, let me show you. Yeah, it's here, right? I hope it is kind of visible. So this is an actual step function from our confab application that I am showing to you. Of course, it is all zoomed out. Let me kind of zoom in. Okay. So what is this? So this is one particular flow which we use to pay money to the organizers. Okay. So which is what we call as settlement. Okay. So what is done here is essentially when people buy tickets, so there are participants who are paying money to buy tickets. That money is first sent to Confab from our payment gateway provider, which is Razorpay in this case. Okay, so participant pays money via Razorpay. Razorpay gives us the money. After some time, I mean, we keep collecting that money. After a few days, we give that money back to the organizer because it is organizers' money, right? So, of course, there'll be some commission percentage platform fee, right? So that will be deducted and given to the organizer, right? Now, very simple, straightforward flow. But now imagine we have to do this at scale. Okay, there are hundreds of thousands of events that happen, and we have to make sure that the payouts, or rather settlements in this case, happen smoothly for every single event, right? So what we did was initially we wrote all of this in code. We wrote it in Python code. We had I think one or two Lambda functions which kind of did everything. So what it would do is, first of all, identify the list of events for which we have to do the payments. Now for each of that event, you have to calculate how much money we have to pay. Now for each of those events, we have to identify who should I pay to. Basically the details of the bank details, right, for that particular event. Now, once we identify how much amount, how much to pay, I have to initiate a payment, right? So that is where again, payment gateway provider like a Razorpay comes into picture, where I initiate a payout I trigger a request to Razorpay saying that, okay, I want to give Raghav 10,000 rupees because he organized the AWS community day, right? Now I tell Razorpay that give Raghav 10,000, right? Now what happens here? This entire flow is not for one event. It is going to it should happen for hundreds and thousands of events without any problem, right? Now imagine doing this in the code level. How many for loops you will have to have, which is what we had. We had so many for loops because there's events, and there's this organizer data, then there's this bank details, then there's this calculation that we have to do per event. It was so messed up. We actually did implement all of this in native code as a single Lambda function. It was so messed up that we didn't even go live with that particular implementation, and we said, okay, there's so much of problem here. It's very complex for someone to understand, and forget someone to understand. If something breaks, it's too difficult to identify and understand, debug, because there's so many for loops, so many things can go wrong, right? So that is when we decided that, okay, we will use step function, right? So what we did, as you can see, what we did was we broke it down into multiple smaller components. Okay, so here we have something called as, the first step is to first understand what are the list of events for which I have to do the payouts, right? How many events are there? First of all, we will decide that. Okay. Now, as I mentioned, there can be hundreds and thousands of events, and each of that have so much of meta information, right? Now, I cannot simply pass that to my map state, or rather here parallel state. Okay, first we have the parallel state. So I cannot simply do it because I told you there's a size limitation of 256 KB. So this is where we use the distributed mode. So what we did was we kind of stored the details in this lambda function to S3. And that S3, I mean, I'm not going to get into this part. Okay, let me get into this. What we do is we first understand here, I have 10, let's say I have 10 events, of which 5 of them have processable data, right? Which means that I have to do the payments, I have to do something. And I have 5 more events where I cannot do anything. So what this lambda function will do is first it will categorize. All it will do is categorize, saying that, okay, these are the events that I have to process and these are the events that I cannot process. So what we will do in the parallel state, what we do is we have a choice state here. Okay. Sorry, we have a choice state. So in parallel, I have one branch for the processable data and the other one for the non-processable data. Okay. Now here in the processable data, okay, yeah, in the processable data, I have the map state. So as I mentioned, because of the 256 KB limit, we store the information in S3. Now to the map function, we simply say that if I can show here is a distributed mode, we are going to get it from S3. The bucket name and file name is passed as inputs. Now this entire branching kind of happens for every event in the input, the JSON file that is in S3. Right now, here what we do, we first fetch the bank details, and then if the bank details is present, we make a payout. If it is not there, we trigger an email saying that, okay, there's no bank details for this event. Like for example, Raghav has generated tickets for 10,000 rupees, but he has not added his bank details, so we can't send it to anybody, right? So we simply say that, we cannot process it, and we send out an email to Raghav just mentioning that, okay, please add your bank details so that we can process. So this is the use of a choice state, right? Now then, if the bank details is present, we try to do a payout. Okay. Now this is where we use the callback pattern. Okay. So in the callback pattern, what we do is essentially we call Razorpay, as I have mentioned, and we trigger, right? So Razorpay is going to do a payment to the organizer. It's going to take us some time, right? So it's according to whatever the Razorpay, whatever we use, it's going to take up to 2 hours for Razorpay to actually tell us back whether it was a success or a failure. Okay. So what we do, this is where we use something called as a callback pattern. And here is where we use the task token. So what is a task token? Is in this particular lambda function, I will say that I want to wait for callback. Okay. So what it means is that once this lambda function is executed, the step function pauses. It won't proceed further until someone from the external world comes and triggers this step function execution and passes the task token and mention that, okay, this is success or a failure. How this works in real world is this lambda function triggers Razorpay, and then from Razorpay we wait for Razorpay to tell us whether it's a success or a failure. If Razorpay says it's success, then we have another lambda function as a webhook, which will read it stores the task token and will come back and resume the state machine, pass the task token and mention that it is a success, and then it will go to notify success. If Razorpay says, okay, we were not able to send the money to the organizer for whatever reason, bank server down, invalid bank details, whatever, Razorpay will trigger our webhook. From our webhook, we will store that, okay, this is the task token. Now that task token will be sent back or will be used to resume this step function and mention that it's a failure. So we go to the failure state. Understand? So here, depending on the third party and using the task token, you kind of pause your step function and decide, and depending on when the third party API returns back, you kind of define what to do next, whether proceed or fail. So Yeah, so that is on a high level of what things work. As you can see in real world, whatever I talked about in this session, in the demo, right? We have the parallel state, we have the choice state, we have the map state, and we have the catch blocks. So one thing that, of course, in the interest of time, I'm not able to discuss is the retry mechanism, right? So as I mentioned, exponential back off in the initial things, right? So for a particular lambda function, you can go to error handling. Okay, so here you can see there are a bunch of retries that we have configured. Okay, so if it's a common lambda error like service exception, lambda exception, you can define what is the error that you want to catch, and you can wait for some time and retry with an exponential back off rate. All of this is available out of the box. You can just input the details here, or you can configure it as a definition here. Of course, the definition might be a little scary because this is quite complex, as you can see. I mean, it's pretty pretty big, as you can see here. But essentially, you can configure at every single point what is your catch, what is your retry, how you want to handle errors, and everything. So and this is the parallel state, choice state. So yeah, that is one live it's the same thing that I showed there, one live example of how we process data with all the features of step function offers. As I mentioned, the biggest advantage that we saw, of course cost is a factor, but the biggest advantage we saw is, as you can see here, right? My lambda function code is very simple. It's hardly 15-20 lines each lambda function. All it does is fetch the bank details, right? It has to go to the database for a particular event because this entire map state is running per event, right? So I pass the event ID, fetch the details from the DB. Missing bank details, I know for which event it is failing. So my entire looping complexity, catch, retry, everything is lifted from my code, making it very simple. And my code, all I have to do is make sure it runs for one event or one input, and the step function makes sure that it triggers for all the data that you pass to step function. So that is the biggest advantage that we saw, and it gave us a lot of visibility into how the data is processing, a lot of flexibility into errors, retries, and everything, which was otherwise more complex if we had to build something at the code level itself. So this is a live example of how we do on Confer. I know, I think I've got probably taken 15 minutes. This is the last slide. So what are the best practices and points to remember, right? The first one is, how do you or when do you choose between standard and express? Leverage S3 instead of passing large payloads. This is what we call the distributed mode. Use timeouts to avoid stuck execution. So you can have timeouts and say that, okay, if it doesn't complete within this timeout, I fail it, right? Move out, retry, wait, conditional execution from your application layer to the step function configuration. This is what I just talked about. We had so much of complexity in our code, which we kind of elevated into the step function, making it much more simple from the code perspective. Use task tokens to await for responses from third-party APIs, and make sure you build for idempotency if you and when you're using express workflows. So that is pretty much it from my side. And this is Rashid Repakula, and I'll be happy to stick around. And if you have any questions with respect to step functions, serverless, or AWS in general, I'll be more than happy to answer them.
Right. Yeah, thank you. I was playing around with. Yeah, thank you for the wonderful, demo. Because when we started the step function, the first 15, 20 minutes, it was like a basic. So when you put that back in a real time workflow, I think definitely, okay, these are the simple things you can easily teach anyone. Okay, this is the map on this is, but when you put it in a big use case that really runs in the production, that really makes a lot of difference, right? So yeah, I could see relate myself like 3-4 years back. I was like exploring step function for one of our workflow engine. Back in time we were like more code oriented person, like we had a different mindset. So like you had we were like thinking like, okay, I have a lambda like Python code, like lambda code also, like some way it works on different use cases. Some like your use case, you can split the chunk of work into minor pieces, and that gets more visibility. You can address the issues only on a particular place. And cold starts, like that is another real pain when it comes to any serverless pattern. So that really handled in this step function. That's great, and a wonderful walkthrough, and you ended with a great the walkthrough of your backend processing, payment processing, settlement processing. Thanks to that, thank you so much, and thanks for providing this session to Coimbatore Group, and I wish to have more collaboration in future. And yeah, thank you, Shashit, for your time on Saturday.
Absolutely. Thank you so much, Raghav, for the opportunity, and great say hosting. Great to see you hosting these events, and hopefully I'll be back for many more sessions.
Sure, definitely. Thank you. And I have quick announcement. I just wanted to take you myself and off from the screen. Um, okay. So So yeah, thank you for staying back with us for more 20 minutes, and it was really interesting. The 20 minutes was the real interesting climax kind of thing. So I hope you all enjoyed, and stay tuned for the community day announcement. We are looking for volunteers, and like I mentioned, for speaker management, event day crew, and social media, and also the content generation creatives. So please send an email to us, awsugcpe@gmail.com, and also we'll send out a communication soon so that you can sign up, and we like know more about you as well before you were part of our community, event crew. Thank you so much for joining us on this Saturday. I hope you all enjoyed this show, and we are continuing to bring in, lineage of this show. Like we'll be having connectivity sessions from Gen AI as well as serverless in the future months. Thank you so much, everyone. Bye.